Hi everyone, an exciting day here at KNWA and Fox 24. Not necessarily for our area when you look up in the sky, but we have technology these days where you can watch a total solar eclipse. It's a pretty rare event. And this one that's happening in about less than 20 minutes or so, there actually is an eclipse that's ongoing and it's already racing across the Pacific. But I'm going to give you a little bit of description as to what you're going to see, and then you'll be able to see it live streamed from a Chilean observatory. Now, there's only been 3 eclipses in recorded history that have actually passed over a major observatory, and this is one of them. So a total solar eclipse is pretty spectacular. You might remember the August 21st, 2017 eclipse. That happened. It was pretty close to our area. Yes, we saw the partial eclipse, but totality ran through Missouri. That was the closest state that had the totality area as it went right through Columbia, Missouri. So just to show you what you're going to see, first of all, what causes a total solar eclipse and why they're so rare is that everything has to line up in what we call synergy. So you have the Earth, the Moon, and the Sun all in line. And as the sunlight approaches the Earth, it gets blocked by the Moon, and the Moon provides this very small, narrow shadow where you have totality that occurs. Now, that is only about 70 miles wide this time for this eclipse. So that kind of shows you what happens. And on the August 21st, 2017 eclipse, we had the umbra shadow, which is the very narrow, dark part of the Moon where you see the Moon totally covering up the Sun. So that's pretty awesome. And then that raced across the United States. Now, this is what a total solar eclipse looks like. This is what we're about to see not too long. The Earth's corona, which is very dim and you can't see unless you cover up the part of the sun, what we call the photosphere, and that is what's so bright when you look at the sky, and you have to have those proper eclipse glasses. Now, if you're looking up at the sky here in northwest Arkansas, don't do that. It's just the same sun. We don't have that position where the Moon is going to be blocking the sun. So that's what you're going to see. There's also some other things that you'll see with a total solar eclipse, and that's going to be down to our south. Again, there's the path of totality that occurs. You get to see the sun's corona, you get to see Bailey's beads, and also what we call the diamond ring effect. It's a spectacular event, and we'll look at a live stream from a Chilean observatory in just a bit. Here's the path of totality. Notice how narrow that is. Notice how, as you work your way farther north, less of the sun gets covered up by the Moon, and that path of totality is running right through that Chilean observatory. Now, the time right now is about 3:20, so we're just about 20 minutes away, a little less than 20 minutes away from totality. And this is a very quick thing. It only lasts about 2 minutes and 30 seconds, where that dark part of the Moon is completely overcovering what's happening with the sun. And then notice how the eclipse shadow races across. And coming up tonight on the news, I'm going to show you a satellite image where we can actually go back in time and you can see the darkening part of the Moon that's totally covering up the sun. Now, as far as the viewing, it's pretty good, but there's people in Buenos Aires in Argentina that are going to be experiencing this eclipse, but they miss the totality. And you're like, well, that's not a big deal. 99% compared to what we have in the totality, it is a big deal, and it makes a huge difference. And so we're going to see that. Now, if you're getting excited about this, and believe me, when you see it, it's not as awesome as it is in person, but you'll be able to see a total solar eclipse, pending weather conditions and cloud cover. Thankfully, we don't have the eclipse today over our area. We have way too many clouds. But on April 8th, 2024, this is the path of totality. Again, people travel all over the world to see an eclipse like this. And so this is the path of totality on April 8, 2024. We're going to take you to that Chilean observatory, by the way. Let's take a look at their live stream, and you're going to see them talking about different things. So we are just about in the process of totality. Now, this is not what's happening right now. This is a look at what you'll see. So there's the corona, there's the diamond ring effect. I don't believe this is an exact live image because totality is exactly 3:38 p.m. Central Daylight Time, and they are an hour ahead. They're in Eastern Time. But this just kind of gives you an idea of what you'll see live in progress. And this is what we call Bailey's beads. These Bailey's beads is where the Moon's terrain, and what that does is when the sunlight glimmers through those terrain effects of the Moon, where you have the peaks and the craters. Where you have the peaks, it covers up the sun, and where you have the valleys, that allows the sunlight to come in. So you see these little what we call rings right here. So, you know, they're looking at different stuff, and that's exactly what they're talking about is Bailey's beads. And The moon is not always the same size because sometimes it's farther away from the Earth, sometimes it's closer to the Earth. And when it's closer to the Earth, you have what's called perigee, and then when it's farther away from the Earth at its farthest point, it's called apogee. You know, you've heard the phrases supermoon. A supermoon is a perigee moon where it's closest to the Earth. Now, typically eclipses only run about 2 minutes and 30 seconds for totality. The one that happened as we had August 21st, 2017, that eclipse lasted approximately about 2 minutes 40 seconds, depending on where you're at. The greatest point of the eclipse will be about close to 4 minutes, and that's happening over the Pacific Ocean. But this is, again, a live stream. They're going to be going to their telescopes. You'll be seeing a small sliver of the sun, and as that sun gets completely covered up, you'll see what's called the diamond ring effect. You'll see Bailey's beads starting to take place, and then all of a sudden, out of nowhere, the sun's corona will appear. And I've heard that there's actually going to be some prominences that are going to be in the sky. And prominences are these big, huge plasma solar flares that stretch out from the sun. And you can't see them when you're normally looking at the sun without the moon covering it up. So it's a pretty spectacular event, and it's pretty exciting. Now, I got hooked on this back on July 11th, 1991. I'll never forget it. We went to Baja. We were west of Baja on an astronomy cruise. I was very young in 91, but I'll never forget that time. Now, that totality lasted close to 7 minutes. It was the eclipse of the century, and you just have never seen anything like it. Here's a look at the sun, and there's those prominences. You can see that with the chromosphere as well as those solar flares that are happening, and we might be able to see some of those as we head into the next, let's say, we're just about 10, 15 minutes away. Again, 3:38 is going to be that time. So this is a live view from Exploratorium. We have Scott Roberts of Explore Scientific. He's there, by the way, and he's checking all this stuff out. And this is pretty awesome that we'll continue to watch this. And so this live stream is really something that you've never seen before, because I remember solar eclipses happening all over the country and all over the world, but there wasn't the technology to stream it. The internet wasn't out there back in the day, and so there was a lot of things that were missing. So I hope you hopped on here, because you're about to witness something that's pretty spectacular. Even on a TV screen, even on a computer screen, it's pretty awesome. Now, this looks like, to me, the corona from the July 11th, 1991 eclipse, although this camera image is pretty spectacular. So, hello, Exploratorium. You can see they've got the shirts out. Now, people travel all over the country and all over the world to see these eclipses, and I'll be one of them, because I saw one. Once you see one, you'll never be the same. It's an unreal experience. Here's some of the things that you get to experience. Not only do you get to see some of the planets that you don't normally see in the sky, you'll get to see Venus, which will be high in the sky, Mars and Mercury. As the sun gets completely blocked, you get a sunset that's all the way around, kind of like casting that sunset hue all 360 degrees around the horizon. And the Exploratorium is in a observatory. It's called Tila Sokolowó, I think is the name of it. I can't really pronounce it perfectly, but that's in Chile, and they're about 7,000 feet up, and they're above the clouds, and there are a lot of clouds, by the way, over the eastern Pacific right now, the southeastern Pacific. So what they're showing you is the terrain effects of the moon and how those Bailey's beads will pop out. So there you see where the sunlight kind of glimmers through, you see those little speckles. Those are the little peaks and craters of the terrain of the moon, and that allows for what we call Bailey's beads. And this is called the diamond ring effect, where you get a little glimmer of sunshine. So, and then there's the eclipse that's kind of a time lapse as what we call last contact, when it hits the very last point of the sun, and then it moves away. So you've got first contact, which is where you just get the first part of the moon that's covering up the sun. Then you get second contact, where it becomes totally eclipsed. Third contact is that diamond ring effect, where it's moving away, or appears to be moving away. And then fourth contact is when it moves off the sun. So as you can see, it's not just all weather. I love astronomy. My stepfather got me interested in that a long, long time ago. Cloud cover is an issue, and on August 21st, 2017, maybe some of you followed me and went along into Missouri and went on the eclipse. And so Yeah, we were ducking and dodging cloud cover. All right, so here we are. We're a little less than, we're just a little over 10 minutes away from totality. Totality occurs at approximately 20:38, so it's going to be in some change. But there's a live look. So this is a live look from the Sierra Tololo Inter-American Observatory in Chile, about 7,000 feet up. And we have permission, by the way, to use this stream on our website. There's a lot of the scientists. In fact, there's Scott Roberts right there. He's getting ready. And you can see that little darkening. It is getting a little darker. But what a lot of people don't realize is that with total solar eclipses, you've got to be in totality. If you're not, and you're just barely out of totality, and you have that partial eclipse where you get maybe 94, 95% of the sun, this is kind of what we saw as we were in Northwest Arkansas, if you didn't get to totality on the August 21st, 2017 eclipse. And heads up, Fort Smith, by the way, if we go back to the weather graphics, I want to show you this because it looks like Fort Smith is in totality, but you're not. So in the River Valley, in a few years from now, exactly 5 years and a little less than 5 years, don't stay in Fort Smith. Travel a little bit farther south. Get into Logan County, get into Scott County, get into Clarksville, the Russellville area, Little Rock. And by the way, the farther away you are from that blue line, the less the totality is. It's a pretty phenomenal and amazing event. And that's why I'm educating you and we're watching this live. So let's go back to that live stream and there you see some people talking about the eclipse. So obviously scientists all over the world are traveling to Argentina, to this Chilean observatory. It's like a whole mesh of scientists and astronomers that are coming there. So also have the Solar Dynamic Observatory, so you can see that. That was the moon that's covering up the sun, but this is a partial eclipse. Here you see some of what we call these sunspots, and these sunspots are real hot spots that release plasma energy and cause northern lights, but they're just kind of geeking out, if you will, about all sorts of stuff with some really cool technology. They will go back to that live stream. If we can we bring up their audio too? I think we can on the Prod PC, and we can kind of hear what they're talking about. And I'm going to bring up a satellite. We're just going to listen to them for a little bit, and then I'm going to bring up a satellite image as I download some data, and we'll be able to see how close that moon is and the moon's shadow is on getting to the Chilean observatory.
Along the path of totality across the United States collect images. 61 of them actually managed to do it. And when those images were knitted together, this is what they got, this incredible three-dimensional view of the corona.
That's awesome. Many lines of sight equals 3Dness. But listen, there's still something for scientists to do, and some people really just got the luck of the draw where actually he made it happen.
Man.
This is Dr. Amir Caspi flying in a jet during the 2017 total solar eclipse under the shadow, so he gets a longer totality, and he got this data in the visible and the infrared while on that jet aircraft.
I hope he kept his eyes on the instruments is all I have to say.
Apparently he did, because here's some infrared white light come on. It's off on one side, so maybe he was looking at the sun.
Yeah.
So, you know what, though? There's still good ground-based data you can get, right?
Absolutely. This was done by who?
This is Druckmüller's software where he combined images.
So what we're looking at here is an image of the solar eclipse with incredible detail because many, many images here are processed and put together in a composite. And I want you to notice a few things because there will be a quiz later. You can see the moon, right? You can actually see a bit of the face of the moon. You also see the incredible corona, and the detail you're seeing is a trace of the magnetic field lines of the sun.
Yeah, so pretty cool. This is the August 21st, 2017 eclipse, and you can see the way the corona is spreading out. I'm bringing up the high-resolution satellite. GOES 17, by the way. It's still downloading the data, but we're going to see a lot of clouds that are going to be over the United States, and then you're going to see this little dark spot that's approaching western Chile, moving through Argentina. And this moon shadow, by the way, races across the ground. It is fast, and that's why the eclipse only lasts just a few minutes, sometimes over 700 miles an hour, the speed of a jet, and even faster than the speed of a jet. Now, this data is downloading because I've never downloaded what we call GOES 17 Mesosector 2, but that's essentially what we're seeing. We'll let this data download, and then we'll continue to get the update. So I can actually see that shadow that's approaching Chile right now on a different computer screen. So let's go, if we still have it, let's go back to the Exploratorium. And we'll go to that stream, and there you see it popping up. And so one of the things, too, that we have is called a solar minimum. You know, there's no sunspots. That's why there hasn't been a lot of solar storms. There hasn't been a lot of geomagnetic storms. There hasn't been many northern lights that have been seen over the last several months. And the reason for that is we don't have these sunspots that are releasing all this magnetic plasma that kind of affects our what we call magnetosphere, which is what allows this northern and southern lights. So here's what are the sunspots. Now, back in 2003, there was a solar storm that happened, probably one of the biggest ones that we've seen besides the Carrington event that happened back in the 1800s. However, there was one in 2003. It was in early November of 2003, and it was probably one of the biggest what we call coronal mass ejections. It was X21, I think, was the scale. Remember, they do solar flares by the size of the scale. They have C class, M class, X class. X class is the highest that you can get. And X class, this is a huge explosion on the sun. And this was a big one where the northern lights were seen all the way down in South Florida and even parts of Cuba. That's pretty rare. Last time we've seen the northern lights around here was on August 27th, or should I say October 23rd, 2011. October 23rd and the 24th, 2011. So again, Exploratorium showing you this different stuff because there's a little bit of a delay before we start to see, you know, totality. And right now the sun's is getting very, very small as the moon continues to cover it up. So they'll go back to a live image here in just a little bit, but we're just kind of looking at some of the stuff that they're talking about, and it's those bright spots, the sunspots that release that plasma and emit that plasma. So we'll let them get back to that. Do we have that live view of, we're still not downloading that satellite data. I'm waiting for it and looking for it, but it's not downloading. So, and I do believe it is goes to mesosectors. Yeah, mesosector 2. It should be loading up, but it's not. Yes, sir. Absolutely. The eclipse does affect the weather. It's very short-lived, but it does. It cools the temperature down. Obviously, if you're blocking out the sun, it's going to cool off the temperature. And what that's going to do is cause, you know, the temperature to drop off, the crickets start chirping. It acts a lot like night. So it almost turns to night in the middle of the day. We didn't quite see that in northwest Arkansas. Also, too, those clouds that are bubbling up, you know, they start to get pretty high and pretty tall. But essentially what happens is those clouds will start to dissipate as the loss of daytime heating is occurring. All right, so we're getting close. We're getting very close now to totality. I'm pretty excited. I mean, this is pretty awesome. It's better to see in person, though, so you don't want to miss the 2024, April 8th, 2024 total solar eclipse. They're pretty rare, too. I know you're like, well, I've seen lunar eclipses before. Lunar eclipses don't even hold a candle to total solar eclipses. They really are totally different. It's a totally different game. But here's a look. 2035. We're just about 2 minutes away. This is about 97% eclipsed. We're getting close to 98. You're going to start to see both ends right here that'll start to shrink down as the moon completely covers the eclipse. A very exciting time. And again, this is from the observatory in Chile. We got Scott Roberts, who is with Explore Scientific, traveled down with the Exploratorium. I'm going to step out of the way. I don't want to get in the way of this shot as it comes into its full glory. This is just an incredible sight. So hopefully a lot of people are watching. That's what it looks like. Still a bright sun. There you see people observing. The shadow has not raced into the mountains yet. And so we're looking off to the west. And by the way, you can see the way that, Chile is pretty notorious for very big earthquakes as well. And you can see all of the mountain chain as a result of that seismic activity. So that's pretty incredible there. One of the biggest earthquakes ever on record, a 9.5, was in Chile. So there's a look at the total solar eclipse. There's a view of it from the observatory. And now you're getting to see, I mean, this is some pretty cool stuff. I mean, when you're looking at it in person, you got those little goggles on and you can't see it quite like this. So they're going to show the Bailey's beads. We're just about a minute away. That's why we jumped on here early. So I don't know how many people we've got on Facebook Live, but we're Facebook Live and we're streaming. And this is a pretty rare event. So we wanted to do this. And a lot of people traveling over 4,000 miles away to see this eclipse. So we are just about to totality, which is at 3:38 and some change. And if we're looking at the atomic clock, we're at 3:38. We're just about to see totality. It's about 99% eclipsed. Still too bright, though, to look at it with the naked eye. You got to have those eclipse glasses. And now you're going to see the edges start to disappear. Sky's turning dark, and again, totality only lasts about 2 minutes and 30 seconds approximately. 2 minutes, 38 seconds. And you're like, well, where's the corona? Where's all that stuff? You can't see it if the sun is even 99.9% eclipsed. It's got to be fully 100% eclipsed. Here we go. We're getting close to countdown. Before we hit 2040 or 2039, we will see, there it is. Here it comes. And so now it's totally black, and oh, there's the eclipse. And there's the Earth's, there's the sun's corona. You can see somewhat of Bailey's beads as well. Oh, look at the prominence on the bottom side of the sun right there. So that red right there is a prominence. Look, there's another prominence too. So they're zooming out a little bit more so you can see some of those prominences. And this is the corona. And the corona, absolutely beautiful and very hot as well. 5 million degrees Fahrenheit in the sun's corona as you have all that heat that's transferring. Look at all those prominences. So you got 1, 2, 3, 4, even with a solar minimum. This is a pretty active sun, even though some of these coronal mass ejections are headed to the Earth. So, but pretty awesome. Now that's a pretty small corona. Look at that. That's a zoomed in view. I've never seen anything like that. That's pretty awesome. So yeah, this is happening live. This is in Chile. We're looking at Exploratorium Stream, and that's a look at the Cerro Tololo Inter-American Observatory. One out of 3 times that a major eclipse, a total solar eclipse, has ever passed over a major observatory. Now this is not going to last very long. So the moon completely covering up the sun. A total solar eclipse is underway. Totality is close to about middle of totality here in about a minute. So you're going to get to see some different shots. We're going to zoom out here a little bit more now. The corona it changes, it alters, it varies, and you can kind of see that corona is pretty small. That's one of the smaller coronas I've seen. Maybe it'll change a little bit, and it could be the exposure of the camera right there in the video stream. But this is just so cool to see. Now the best is the diamond ring effect, in my opinion, where what's going to happen is as the moon moves away from the sun, as it moved this way, it's going to brighten up on the bottom side of the sun. You're going to get to see that diamond ring effect. Look at this brightening right here. That's pretty awesome. Oh, there it is. We're already starting to see the diamond ring. That was less than 2 minutes right there. So there's the diamond ring. There's the corona, and that's it. That was a very short totality. Wow, that was pretty quick. Look at that. A 360-degree sunset. Some of the things you can see from the sky, but that was it. That was a pretty quick totality. That was a lot less than 2 minutes and 40 seconds. It was about 2 minutes and 20 seconds at best. But pretty awesome there. There you see the sun, the 360-degree horizon looks like a sunset. And that's it. That's the end of totality. And it doesn't last long, but boy, it's a life-changing experience if you've ever seen it in person. The one that happens, by the way, in 2024, April 8th, 2024, is going to be right over Arkansas. Hopefully cloud cover doesn't disappoint, because we know that in middle of April we get a lot of thunderstorms. So if you really want to see that, we'll have to continue to watch. But there it is. That's the end. And then the moon just continues to move away. This is third contact right here. Fourth contact is after the moon moves completely off the sun. We're going to end this Facebook Live. I hope you enjoyed that. That was pretty awesome. It didn't last very long. It was actually shorter than I even thought, and I think shorter than expected times, unless we were just having fun geeking out for a while. But that's pretty awesome right there. So thanks to Exploratorium for allowing us to view the total solar eclipse of July 2nd, 2019. And remember, we'll keep you up to date as we get closer to 2024 on all the eclipse viewing and everything that you need, and eclipse glasses and all that stuff. And we'll be probably around 98, 97, 98% total eclipse, but you won't get to see any of that other stuff, the corona, Bailey's beads, as well as the diamond ring. Boy, that's pretty awesome. All right, so for Chief Meteorologist Dan Scoff and a amateur astronomer, I appreciate you guys watching. Hope you enjoyed the total solar eclipse of July 2nd, 2019. We'll be back with a weather update tonight on the news on KNWA and Fox 24. Hope to see you then.